This module is going to be about agile game and simulation development. We learned something about system architecture previously, and we talked very lightly about the future being something cloud-based, service-oriented architecture, a trend toward modular interoperability, but we didn't really speak specifically about what that actually means. So this module is just going to be some of my own thoughts from my own experience on where that might actually be heading and why it's different from what we're doing today. So this is, we have some experience in this sort of things. This is America's Army that was built at the Moves Institute years ago. Commercial game engine, real high grade stuff, very high quality, um, very successful program. But so what if you just invested a lot of money in this? You've built this thing up, and then somebody comes along and says, now I want to do this. I want to do this. I want to do this convoy trainer, and it's got a lot of things in common with that America's Army thing, but it's not the same. We got some different requirements. We want to do something different. So the question that you have is, what can I use in common? They are both putting pixels on the screen. I've got vehicles. I've got people. I've got environmental effects. I've got lighting. I've got physics. I've got all these things in common. How much overlap do I get from one to the other? And of course, the answer is pretty obvious. You get zero. So my question was, how do I get some sort of sharing between these two? Knowing that I can't get everything, can I at least get something? And I think the answer has something to do with a modular approach, which then lends itself to cloud computing and service-oriented architectures. So let's take a different view. Okay, let's not talk about first person type stuff. It's real easy to fall in that trap where we think that all of modeling and simulation is first person shooter types of apps, when in reality that's a little part of what we do. Here's the bigger stuff, is things like SAFs, right? So one SAF, a semi-automated force, big program, used in lots of different applications, and I'm going to build a couple of models. I'm going to build a tank model, and I'm going to build a helicopter model, and I'm going to make them compatible with one SAF, and you've put me under contract, and I'm going to build this stuff out for you. Okay, so great. I package them up using the interface that you say that I have to use, and I make them work in one SAF, and you're a real happy guy, so we're good, right? Until you go along and you say, well, wait a minute, I want to use JSAF now. I got a different requirement. We're gonna do something that's not just Army. We're gonna be doing. It's gonna involve Navy, and we're gonna be using JSAF now. So I want to use those. I want to use those same modules. So what do you think is what do you think are your chances of being able to take these two models that you just built, you just paid good money for, you did all the right things, you plugged them into one SAF. Now I want to use them in JSAF. Well, in reality, it doesn't work at all, and you're essentially going to have to rebuild them. You won't be happy about it, but that's reality. Now, if you don't know what this is the ITSEC floor. We go there every year at the end of the end of the calendar year, and lots of vendors are there showing off their stuff. And let's say I was just interested in rendering engines. I want to do high fidelity graphics. I want to put pixels on the screen. I want to feed geometry into an engine and have it put pictures up on a screen at 60 frames per second. How many different examples of that do you think you'd find on this floor? Well, they're all over the place. Everybody's got one. Are they all different? Maybe not, but pretty close to. Everybody's building their own. And who's paying for all this stuff? This isn't easy stuff. This is a lot of engineering hours that go into this, and yet we keep rebuilding the same stuff over and over again. So I love these quotes from Lou Gerstner from IBM. This is dated. He's not at IBM anymore, but I love this, where he says, "This is the only industry where competitors don't regularly agree on standards to enable greater value for their customers." He's talking about the software industry. And his staff said, "Let us explain about lock-in, network effects, de facto standards, and the 5 ways to play." These are just basically all mechanisms that IBM was using to lock their customers in and eliminate their choices so that IBM could get downstream cost. And the CEO responds with, "That's interesting. Let me get this straight. You're telling me the strategy is to lock in our customers and then gouge them on price," which is exactly what they meant. And he's not alone. This is just about everybody in the software industry thinks this way. So we're thinking about ways of breaking out of this. And again, think back to a comment that was made earlier, which is open source is not the solution. In fact, it can bring a whole different set of problems into the picture. This is an architecture issue. So what I really want to do is I want to reduce the total cost of ownership. I want to reduce or eliminate licensing costs wherever I possibly can. That's going to be key. I want to accelerate initial development and modifications where possible. And here's a big one. I want to stimulate innovation and competition. It doesn't do me any good that everybody on the ITSEC floor is implementing their own scene graph rendering engine. That's not innovation. That's a waste of time. We've all built these. There isn't much of a difference in any of those things. Somebody wants to come up with something that's radically different as far as, using holographic displays. That's innovation. Doing 3D graphics is not innovation. Let's not kid ourselves. I want as many of our dollars going into innovation as possible. So I got to create a market to be able to do this. And I'm not really creating a market because I'm allowing everybody to re-implement the exact same stuff and sell their products to us, the government, on the basis of something else. So we're going to accomplish this through an agile, open architecture. Been beating the drum for a while. This is an architectural issue. So think about how this is built today. This is just a simple block diagram of a typical modeling and simulation application. The application is in blue. It sits maybe on top of some engine. It could be a game engine, could be a sim toolkit. It's some application programmer's interface. And underneath that is a whole set of modules. You've got your scene graph, that's your graphics. You've got your audio, we're probably doing 3D audio. You've got some ability to do physics and physically based modeling. You maybe have character animation, so you can have people walking around. You've got device I/O, so I can display. I can have maybe 3D trackers. Could be a joystick, whatever it is, a stick and pedals. Networking. I want to be able to network this thing. I want to do interoperability. I want to be able to do HLA. I want to be able to hook different systems together. I want to be able to hook to the internet to draw data in. These are all normal things every application is going to want to do, and these are all sitting underneath the toolkit or the engine API. So now you say, I want to build my America's Army infantry simulator. Great. You just said, because that was built on Unreal, that I've now bought into the Unreal Engine and it has its set of modules. So I'm standardizing to that whole thing, which gets me that particular set of red boxes because that's what Unreal gives me. And when I move along and say, now I want to do my MetaVR convoy trainer, what did I just do? Well, I just said, wait a minute. I said the physics aren't suitable now. I got to change that. And the character animation isn't suitable. I got to change that. And I've got a few shaders that I want to put into my scene graph because I've got some graphical effects for IEDs or whatever it is I have to do for my convoy simulator that you didn't need in your America's Army simulator. So I got to make just those few changes. The audio is just fine. Love it. The device I/O, just fine. The networking, just fine. All the other stuff, great. I don't want to touch that stuff. But you made a choice at the engine level. You'll be changing the entire engine. So what I really want to do is I want to just swap out these little pieces in between. That's really what I want to accomplish. So what I end up with here is two different implementations on two different engines that have lots of the same parts, and I get to pay for all of it twice. Not very cost effective. You might say, hey, that's just the cost of doing business. I had different people doing the work. But if you were in one program office responsible for both of these applications, you should rightfully take some heat for paying for the exact same stuff twice. So let's sort of think conceptually about what we're talking about here. Well, I've got for whatever my available funding is, I got to do all this stuff. I got to have core functions. That's my physics, my networks, my graphics, all that kind of stuff. I'm probably going to have some proprietary features, some things that are unique to my program that I had to build just for this program. Then I'm going to build applications on top of that stuff. And then at the end, it's a big box, but I have to service it, I have to maintenance, I have to maintain it, and I got to upgrade it for however long this program is going to run. And I got to pay for all this stuff. What we're thinking about doing is this: taking at least those core functions and drop them below the line, open source them. They're commodities. I don't want to pay for them. And then I want to pay for my proprietary features. I want to pay for my applications, of course, because those are unique. And my service and maintenance, I got to pay for that too. So I get some kind of a cost savings here. There's another way of thinking about it, because in a lot of cases, maybe your program has a certain level of available funding and saving them money isn't what they want to hear. Well, maybe they want to hear this instead. For the same amount of money, I'll give you more. I'll increase your capability. They probably like that. So either one of these is a win. And it's only possible if I use open source just for the core functions to drop it below that line. But think about what I just said. I'm not saying open source the approach. What I'm saying is open source the core functions, but allow me to put proprietary stuff in there as well. So I got to have a different way of thinking about this. If you haven't already subscribed to Software Tech News and you're in our industry, you probably should do that. It is, I don't know if it's still an actual paper publication or if it's now just an e-publication, but it's put out by DAX, and it is excellent. It talks about all the most recent and important innovations in software technology, but it always gives it a heavy, heavy DoD focus, and that's a really good thing for us. So what we're going to talk about is we want to mix open source with a service-oriented architecture, and this is how we're going to do it. We're going to separate these three things. This is our architectural approach, is to separate data from application logic from interface. And what we're going to do is we're going to think about that, a web browser or something like that as the interface, although we're not going to do that exactly, or we're certainly not going to limit ourselves to that. But I'm going to have, in a typical SOA, I'm going to have modules that do things like authentication, query management, all sorts of different things. And I'm also going to have different data sources. And then what I'm going to do is I'm going to have a service producer, that is folks who provide services. They're going to publish those into some registry and something called UDDI. It's a discovery interface, a universal discovery interface by which service consumers can discover what's available, and then we bind the consumer directly to the producer. So this is a typical SOA approach for distributed computing. We see this in industry all over the place. Big industry is using this everywhere now because it cuts. It's a great architectural approach, and it allows us to deal with things independently. So our goals are to be flexible. We want to encourage reuse wherever we possibly can. I want to demand interoperability. I don't even want to allow you to not interoperate. I want to accelerate development and modification. I want to encourage innovation and competition. I want to lower the total cost of ownership so that you buy or build only what you need, and if you've already paid for it, you're not paying for it again. And one of my biggest problems here is that traditional web services, like what I just showed you on the last slide, are typically too slow for real-time applications. I don't have time at 60 frames per second to be doing my offloading through a web protocol where my computation is happening on some server that could be miles and miles away. It's probably not going to perform like I need it to. So I need some sort of a compromise. This is what I came up with. So what I want to do is I want to have a runtime kernel, and this just does some basic stuff. It handles your system, your data types. It has what we call an object model that makes a generic form of what all your objects are, inputs, messaging, and script. So it's basically the architecture, it's the rules by which all of your interoperable modules that you're going to put in are going to communicate with each other. Now I want to build America's Army, and what it actually looks like is an XML manifesto, which is just it's just a list of pieces. So you look in this, you've got rendering, audio, physics, character, it's all those things that we just talked about, and it's just going to go get those. And at runtime, it goes and snags all those different pieces, pulls them locally, doesn't execute them remotely, but actually acts like a service-oriented architecture or cloud computing, but it runs them locally. And what's the advantage? Well, now when I want to build my convoy simulator, new manifest, I changed out my physics and my character animation. Remember, those were the two modules that I said were different. Everything else is the same. Well, all I do is I go grab myself a new physics and character animation module, and I run again. So there's my advantage. I get maximal reuse. Everything that I didn't need to change, I didn't change. And what I can do with this runtime kernel is I can now think about even running it on handheld devices. So I can have the same application running on an iPhone or an Android device. And the way this is going to look when I implement it in the large is I'm still going to have some registry. Here's my cloud, and I've got a bunch of proprietary and open components. You could even have classified components as long as you maintain that if you use any classified component that the entire thing runs in a fully classified environment. But they all talk to a registry, and I've got my urban ops application with its XML manifest, and I can do my helicopter simulator that has its XML manifest, and they both pull the modules that they require, and only the modules that they require, and maximize reuse by reusing all the base stuff that they both have in common. So, to wrap up, open source clearly is a critical part of achieving cost-effective, flexible M&S software development. There's no question in my mind, but I don't want to have to choose open source or proprietary. I want it to play well with proprietary software, but you got to give it a chance. You got to have an architecture that allows it to do that. Service-oriented architectures or cloud computing encourage reuse, flexibility, and cost efficiency, but if you take them literally, they're too slow for most M&S applications, which is why they haven't really taken root. Open source plus some form of real-time service-oriented architecture encourages innovation and competition because it focuses all our energy in the stuff where money can be made, and it creates a marketplace for those things. And we, that is DoD M&S professionals, have got to be the architects of these systems. We don't get a choice. We have to be the architects so that our vendors can focus their energy on what we want them to be innovating on and not basically selling us a re-implementation of something we've already paid for multiple times. So that's a gist of how I see cloud computing and service-oriented architectures playing an important role in the future of real-time modeling and simulation, both 3D first-person shooter types applications and SAPs or anything in between. Having an appropriate mix of open source and proprietary and things that are running on your local hardware and things that are running remotely. They all have to live in concert together.